Nesting means when you place one code structure inside another. For example, if statement within if statement, or a loop within a loop, or a if statement within a loop, or vice versa. But you should not do it over two. Why? When you start with a basic function, it's nice and simple, just level 1 deep. But what happens if you add one if statement within it? That's level 2 deep now. And now, let's throw a loop, and you're diving even deeper to level 3. And if you go deeper, like level 4 or more, things get complicated. It's best not to overdo it. I will explain in a moment the best approach. Before that, did you know that nesting code adds a higher cognitive load to your thoughts process? What? Yes, that's true. When you write nested code, it demands more and more deep understanding layer by layer. Just imagine reading a story within a story, and then another story inside it, and it becomes a challenge to keep track where one story begins and ends. Similarly, with the nested code, you are juggling constantly in your mind. If you find yourself struggling with refactoring, relying on debugger too much, reading too many commands, experiencing code fatigue, these are typical indicators of cognitive load in your coding process. In very simple words, cognitive load refers to the mental effort required to process information and complete tasks. In coding, when your code structure is complex or disorganized, it increases the cognitive load, making it harder to understand and debug. And the second is ineffective code metrics. One of the primary reasons to avoid deeply nested code is the impact on code metrics. Many developers rely on to evaluate the quality, complexity, and maintainability of their code, like Cyclomatic Complexity, Maintainability Index. So, it affects. The third is loss of abstractions. When you write over nesting in your code, probability is you are going away from the solid principles, especially single responsibility principle and open close principle. Too much nesting often means a function doing many things. This goes against the single responsibility principles, which says a class or function should do just one thing. Also, when you nest a lot, you lose clarity and quality. Good code is not just working code. It should be clear, efficient, and easy to expand. And the fourth one is code smell indication. Excessive nesting is often a code smell. It indicates that the code has been patched multiple times without proper structuring. Code smell does not mean that there is a bug, but it suggests something is wrong or out of place. Code smells often points toward poor design or development practices that might make the code harder to maintain or extend in the future. And the final point is remake. Readability, maintainability, and testability. The deeper you nest, the harder it becomes to read. Now the million-dollar question is, what is the ideal depth of code nesting? The ideal depth of code nesting is typically 2 or maximum 3 levels. Beyond this, readability and maintainability can be compromised. Always aim for clarity over deep nesting. Now the next question is, how can you minimize or replace deep nesting? With 3 simple ways. Early returns. Exit functions early using guard classes to reduce nested conditions. Do you remember the function I shared with you when I talk about code smell? Here is the way to use guard class. The second way is break functions. Split larger functions into smaller, more manageable ones. And other way is use switch case. Opt for switch case structure instead of lengthy if-else. To be honest, there are more ways to avoid deep nesting, like flatten callback and design patterns like state patterns and strategy patterns for decision making. Now I will talk about 2 practices that you can use to avoid deep nesting. First is code review. Regular review can help identify areas with excessive nesting and pair programming. Working in pairs can prevent overly complex code structures. And finally, there are tools available for every language that you can use to avoid nesting. For example, for Python, tools like Flake8 or PyLint can highlight complexity. In JavaScript, ESLint and TSLint can be configured to warn about nested blocks. And in C#, extensions like CodeRush and Matrix.net and so on. Simplified clean code can reduce this mental strain, letting you focus on problem solving and innovation. Want to discover the secrets behind the world's best coders? Dive into this video, Mindset of Successful Programmers. It's a game changing, and thanks for watching.